This is a video key for the CFA for 1.3 through 1.5, version A. So for number 1, you're just finding the coordinates of the midpoint. You have to know the midpoint formula. It's not that hard to remember. It's just the average of the x's and the average of the y's to find the midpoint between any 2 points. So if we're trying to find the midpoint M of UR, then we are specifically looking at these 2 points. So all we have to do is average the x's, average the y's. And it's a coordinate point, so I'm going to put it in parentheses. So the first x is -4, and the second x is 2. So we're going to add them together and divide by 2. That's the definition of an average between 2 numbers. If it's more than 2 numbers, then you would divide it by how many ever numbers you have. So that would just change the denominator. But this is just the average of 2 numbers. Then we're going to average the y's. So the first y for u is -2 plus the y for r, which is -3, and divide that by 2. So it's not that hard a formula to remember, so you got to get the formula and then do some really easy math. -4 plus 2 is -2 divided by 2, and then over here, -2 plus -3 is -5. If you're having trouble with adding these, which you shouldn't be, really, just use a calculator. Divide by 2, and then -2 divided by 2 is -1, so that's our x coordinate, and then -5 divided by 2, you can leave it like that, -5 halves, but if you want to convert it to a decimal, that's okay too, -2.5. That's it for number 1. For number 2, we are finding UR. Notice there's no bar over top, so I'm talking about the distance of UR, the length of that line segment UR. So in order to do that, we have to look at UR again. So we're looking at the same exact points that we did for number 1, but we're doing distance formula. Distance formula is another formula you have to know. It's simply the difference of the x's squared and the difference of the plus the difference of the y's squared, and it's the square root of all that. That's a distance formula. Because remember, this is just like the horizontal leg of a right triangle, vertical leg of the right triangle. A squared plus b squared equals c squared. So it equals just regular c, or d is what we use for distance, because we took the square root over here. So we're just plugging in the values. So I like to write all this first and then put the square root, but don't forget the square root. So second x, here's u and r, the second x is 2. So it's going to be 2 minus, put that minus right away, then x1, and x1 is negative, so you're going to have 2 negatives in a row. So it's 2 minus a -4 squared plus our second y, which is -3, minus, put that minus right away, our second y, which is a -2. So we have minus and negative twice in this problem, and it's the square root of all that. That's what UR is going to be equal to. So remember, when you are subtracting a negative, that's the same thing as adding a positive, so that changes to 2 plus 4, and over here it changes to -3 plus 2. And it makes sense because we're just looking for the distance between -4 and 2. Those are 6 units away. Makes sense. 2 plus 4 is 6. These two are 5 units away, or sorry, 1 unit away, because we're going to get a -1, but remember, when we would actually talk about distance, we would take the absolute value of that. But we don't need absolute value because we're going to do what with the number? Square it, so it doesn't matter that it's negative. Okay, so then we get 6 squared. I'm not putting parentheses around it because I don't need to, since it's positive. But I can. I would just suggest you do if you're making mistakes like that. Then -3 plus 2 is a -1 quantity squared, so the whole thing is squared. 6 versus 6 with parentheses is no different. -1 versus -1 -1 with parentheses versus -1 without parentheses are very different. You have to have the parentheses, okay? Because it's supposed to have parentheses. The only reason why I can drop them here is because 6 with or without parentheses is no different. But -1 with or without parentheses is very different. Remember that without parentheses, this means actually the opposite of 1 squared. The negative's not being squared, so that's equal to -1. But when we have in parentheses, it means -1 times itself, which is a +1. And that is what it's supposed to be always in the distance formula. It's always the whole thing. The negative should be squared. So don't write this and then say that's equal to +1, because I'll take off more points, and I've told you that before. All right, so we have that, and then 6 squared is 36, and -1 quantity squared is +1. equals, and so that's square root of 37. And no, you cannot square root these separately. We've talked about that, remember? It's not the same because the square root of 36 is 6, the square root of 1 is 1. Square root of 37 is not equal to 7. You cannot square root separately when you have a sum. You have to add first and then square root. So this is an irrational number. So the exact answer is that irrational number, that square root of 37, and the estimate is when you put square root of 37 into the calculator, to the nearest tenth will give us 6.08. In the calculator it does say 6.0827 yada yada, but the 2 did not round up the 8, so that's why it's just 0.08. All right, moving on, number 3. We are finding the coordinates of Q if R is the midpoint of QS. So you have to solve this using an equation, but drawing a picture will help to understand what's going on here. So QS is your segment that you're trying to find, or that we're looking at, and R is the midpoint. So R here in the middle, and it's QS. And we're trying to find Q, so we don't know the coordinates of Q. So I'm just going to give those variables here, x, y, but I do know the coordinates of R, because remember this is for problems 1 through 3. So R is 2, -3. I know that that's the midpoint, and then S is -1, 5. So on this one, instead of finding the midpoint, we're finding an endpoint. So we're just going to take this and work backwards. So instead of plugging in both of these and finding the x value of the midpoint, plugging in both the y's and finding the y value of the midpoint, we know this starting off, and we're trying to find one of these. So it's like we know this one but don't know this one. Know this one but don't know this one, but we know what the final result has to be. So let's set it up like that. So if I was setting up an equation, or if I was trying to find the midpoint, I would take my two endpoints. So that's x, -1, those are my x values, x plus a -1. I would divide that by 2, find the average of the midpoints, and then I would take the average of the y's, y plus 5. And again, I'm using a variable because I don't know it, divided by 2. So how are you supposed to solve something if you don't know one of the pieces? Well, I know the result. I know that that has to eventually become 2, -3, because I know what the midpoint is. So this has to equal 2, and this has to equal -3. Those are your equations. That's all it is. So these two have to be equal, and these two have to be equal. So let's just write that equation over here. X plus a -1 over 2 has to equal 2. Then y plus 5 over 2 has to equal a -3. All right, now when we're solving, don't get confused. I had some people get confused on this. But to get rid of the 2 in the denominator here, you have to multiply by 2. So we're multiplying the whole side by 2. So it's like 2 over 1. Okay, same thing on this equation. Now you don't distribute the 2 because it cancels out with the denominator. If you do want to distribute the 2, here's what you would get. I'm going to do it off to the side here. You get 2x plus a -2 over 2. So you still didn't get rid of that 2. If you distribute the 2 throughout the numerator, you haven't done anything with the denominator. So then you'd have to divide these separately by 2 because it's a fraction, so you divide each piece by 2, and then you'd get x plus a -1. Oh, that looks familiar because it's in the numerator. So this will undo dividing by 2, right? You had half of this. Dividing by 2 is half. So you had half of this. You're doubling it. So now you have a full this. What's this? It's the numerator. So these just cancel out. And you're left with what's ever in the numerator, which is x plus -1 equals 4. On the right side, same thing happens. We're going to cancel those out. They undo each other, and then we're left with y plus 5 is equal to -3 times 2, which is -6. And then look how easy these equations are to solve. Not hard. -5, so y equals -11. So our original endpoint, Q, has to be +5, -11, in order for this to be the other endpoint and this to be the midpoint. And our final answer always goes in parentheses, so 5, -11. And that's it for number 2. Moving on to number 4 here and 5. So this one I can put in a separate video because I need to get out my protractor. So we'll go on to the next page. All right, on this page, we are looking at first number 6. Show all your work clearly here. So for number 6, we got to look at the information given. We are told that we want to find the measure of angle ABE. So let's highlight what angle measure we're looking at. ABE. We want this angle. That's our final answer, is going to be the measure of that angle. If BE, ray BE, which is this ray here, ray BE, bisects angle ABD. So angle ABD is this big angle. Okay, so it bisects it. So we know bisect means cut in half. So if ray BD or BE is bisecting this angle, what do we know is true? We know that this angle and this angle are congruent. Oops, it straightened out on me, that angle. So we know those two angles are congruent, so that means we can create an equation that we can solve here. So I know that the measure of angle ABE right here is 7x minus 38. So that's 7x minus 38. And then this one is 2x plus 47 because that's EBD. So you just have to set these two equal to solve, and that's it. So let's do that here. All right, so we have 7x minus 38 is equal to 2x plus 47. So get like terms on the same side, so I'm going to subtract 2x from both sides. So after you get this, guys, it's not a hard equation to solve. 5x minus 38 is equal to 47. Then we're going to add 38 to both sides. And notice how I'm actually showing my work by putting to both sides. So we have 5x is equal to, that would be 85. Divide each side by 5, we get x equals 17. That's great and all, but that's not our final answer. Our final answer is, what is the measure of angle ABE? So the measure of angle ABE, we had an expression for it. And notice my notation here. You have to have the measure of the angle, not just angle ABE, the measure of the angle. Angle ABE without the little m just means the physical angle. So it doesn't make sense for it to equal a number. So now we're going to plug in 7 times our x, which is 17, minus 38. 7 times 17 would give us, 17 times 7 is 119, minus 38, and that will give us 81. So the measure of angle ABE is equal to 81. How can we check our answer? Well, you can check it back here or just check it on this side, because we already know that 7x minus 38, I did it over here, is 81. So we can do a quick check. 2 times my x, 17, plus 47. So that would be 34 plus 47, and yes, that is 81. So it checks out. So the biggest thing on this one, you have to know that bisect means to cut in half, and set these two equal and solve. For number 7, the biggest thing you have to know here is that these form a linear pair. Remember, a linear pair are two angles that are adjacent. So these two angles, angle 1, I'm going to highlight angle 1. Angle 1 is right here. And angle 2 share a side, so you can see the shared side. I'll highlight it in blue. That's their shared side. So they're adjacent, have that shared vertex, and their non-shared sides are opposite rays. So the pink line and the green line here are opposite rays. So it forms 180 degrees. So you have to know that. You have to say, hey, that's a linear pair. And then, oh, because it's a linear pair, guess what I know? This whole thing is 180 degrees. So I know that the measure of angle 1 plus the measure of angle 2 is equal to 180 degrees. And then you just solve from there after you recognize that. That's the only thing that's additional between what you've learned in algebra and geometry. It's just you got to know it's a linear pair. The algebra from there should not be hard. So measure of angle 1 plus measure of angle 2 equals 180. Measure of angle 1 is 4x minus 3. Oops. And then we're adding to that, right? This plus sign is this plus sign. Measure of angle 2, which I told you is 3x plus 8, equals 180, and we're going to solve. Combine like terms on the same side, 7x. Combine like terms, negative 3 plus 8 is positive 5, is equal to 180. Subtract 5 from both sides, and you get 7x is equal to 175 divided by 7, and 175 divided by 7 is 25. So we've got x, and we were told to find a value of x and a measure of angle 2. So I'm going to box that up since it was part of my answer that I asked for. On number 6, we did need x, but it didn't necessarily wasn't part of our final answer. And then measure of angle 2 is equal to, so you can't do measure of angle 1 because these are not equal like over here was. Those two angles are the same. These are supplementary angles. So measure of angle 2, we have to use this expression, 3x plus 8. So 3 times 25 plus 8. 3 times 25 is 75 plus 8 is 83. So that's the measure of angle 2. We can check our answer easily by figuring out what the supplement would be. So 180 minus 83, okay, that would be 97. And we're going to make sure that measure of angle 1 would equal 97. So measure of angle 1 with our x here, 4 times 25 minus 3. 4 times 25 is 100, and 100 minus 3 is 97. So we got matching numbers here, so we know our answer is correct. And that's it for number 7. Next up is number 8. So another angle relationship you have to know. Then the algebra is easy. So you should be able to see here, we're trying to find x and y. So if you did well on number 7, you would have noticed on this problem that, oh hey, we have another linear pair there, or you could say the linear pair is here. But we don't know, we have two unknowns with that. We could say 2x plus 44 plus y is 180, 4x minus 20 plus y is equal to 180. And then you could do a system of equations, all that business, but guess what? You don't have to do that. It's a lot easier than that because we have vertical angles. Remember that vertical angles are two angles that they're going to be formed by two different lines, but they share a vertex, and they're formed by just two lines here, okay? So just like this. So they're non-shared sides. Each pairs of them form opposite rays. So this one is opposite ray to this one's an opposite ray to this one. So that means that these two angles are vertical angles. And we know that vertical angles are congruent. That is a big thing that we need to know. So not only is that true, but then this would be y as well. These two are also a pair of vertical angles. Anytime you draw two intersecting lines, you get two pairs of vertical angles. So since these two are equal, set them equal. So we have 2x plus 44 is equal to 4x minus 20, and we got to solve that. Again, the math from here is not hard. So we get 2x minus 20 equals 44. We're going to add 20 to both sides now. Again, I'm showing all of my work here. A 64 equals 2x divided by 2, and you get 32 is equal to x. So that's one of the things I needed to find. Now I had some people then say, oh, well, x plus y is 180. They said, oh, x plus y equals 180, so 32 plus, no, not right, wrong, because that's not, x is not the angle, x is this piece right here. The whole angle is this 4x minus 20, or the 2x plus 44. So you have to find the measure of that angle. So we're going to do 2 times 32 plus 44. We get to 64 plus 44, and that's going to give us 108. So that's this angle. It's 108 degrees, and this angle is 108 degrees. So now we can find the measure of angle y by knowing that 108 degrees plus y has to equal 180. So you're just taking away 108 from 180. Make sure you're using a calculator if you're not going to, just make sure you're not making mistakes, but it's just 72. So y is equal to 72, which means that whole angle is 72 degrees because y is the whole angle. Here, x is not the whole angle, it's just part of the expression. And that's it for number 9, or from number 8. All right, for number 9, we've got one of those complement supplement problems. So this one's just talking about a complement. There are lots of different ways that you can do this problem. I'll show you first the way that I always do them. So first of all, we're talking about an angle and its complement. The difference of an angle and its complement is 14. That means the angle is bigger, okay? That has to be bigger because the difference is positive. The order matters. Its angle minus complement is 14. So we're going to say let x equal the measure of the angle. So if x is the measure of the angle, then always the complement is 90 minus x. If you know x, you would take it away from 90 to find the complement. So that's the complement. That never changes. 90 minus x is the complement if x is the angle. All right, so what do you know about those two things? You know if you take the angle minus its complement, that equals 14. That's what I told you. The difference minus the angle and its complement, angle, complement is 14, equals 14. What did we use for the angle? We used x. Minus, what did we use for the complement? 90 minus x. You have to put it in parentheses. Otherwise, you're going to get no solution, and you know that equals 14. There you go. Solve this, but you have to distribute the negative. I had some people get this and not distribute. So it would be x minus 90 and then plus x because you're subtracting a negative x equals 14. You can solve it from there. That'll give you the angle, and then you can subtract from 90 to get the complement. Another way you can do it is if you say that x is the complement, then you know that the complement plus the complement plus the angle, and you know the angle is 14 bigger. You could say x plus 14. So you can say this is the angle, and this is the complement, and that lets you do addition instead of subtraction and having to distribute a negative. So x plus 14 is equal to 90. Or you could have done it where, again, x was the angle, and x minus 14 is the complement. You could have done it that way. That's the complement because it's smaller, and that's the angle. And when you take, because if the difference between an angle and its complement is 14, that means you take the angle minus 14, and that's the complement. So the complement is 14 less than the angle. And you know the angle is x, so x plus its complement would be 90. You can solve that equation. Or you could do it another way. You can say, okay, I know that the complement is 90 minus x, but I also know that the complement is 14 less than x. So x minus 14. So complement, or x, the angle minus 14, that's the complement, but I can also write the complement as 90 minus x. You can solve that equation. There are so many equations you can solve. Just for this one, you got to make sure that you realize that you had x as the complement rather than the angle. So solve any of those equations, and it will work. So I'll just solve this one. 2x minus 90 equals 14. You add 90 to both sides, and you get 2x is equal to 104. Divide by 2 is 52. So x is 52, that's the angle in that equation. Then I just do 90 minus 52 to get 38. That is your complement there. And you'll get that same answer no matter which way you solve it. All right, that's it for number 9. Let's go to the next page to do number 10. All right, for number 10. There are still different ways that you can do number 10, but I'm going to show you the easiest way. If you know a different way or you like to use a system, that's okay. But if you use a system, you still can only have 2 variables. Or you can start with 3 and then do a bunch of substitution and get down to 2. So it says that the measure of the supplement of an angle is 22 less than 3 times the measure of the complement. So I need the complement, I need the supplement, I need the angle. So it sounds like 3 different variables to start. But we're going to just use one. Let x equal the measure of the angle. Just like number 9, no matter what, if x is the angle, its complement is always 90 minus x. Because if you know x, you're going to take 90 and subtract it to find the complement. That never, ever changes. Same thing for supplement. The supplement would then be 180 minus x. Because whatever x is, if you know the angle, to find its complement, you're going to do 180 minus that angle. So that will always be the supplement. So we've got the pieces here. So let's read that problem again. The measure of the supplement. Right here. Measure of the supplement is, so that's an equal sign, 22 less than. That means you're subtracting 22. 22 is being subtracted, so that will come at the end. What are we subtracting 22 from? 3 times the measure of the complement. Oh, look, measure of the complement. Okay, I'm going to do some highlighting here to help us here. Measure of the complement. Well, here's the complement right here. And then this one was measure of the supplement. And then here's measure of the supplement right here. So supplement is equal to 3 times the complement. So 3 times that whole complement. So I have to put in parentheses 90 minus x. So again, that is the complement here. And it's 22 less than that. So we're going to do minus 22. So you can see the measure of the supplement is 22 less than what? 3 times the measure of the complement. That's it. The setup is the hardest thing. After this, you should be able to solve it pretty easily. You got to distribute though. And again, there are different ways you can do it, but I'm only going to teach you one for this because it's just going to be too complicated otherwise. The other one I could quickly show you those things. All right, 3 times 90 is 270. And then 3 times negative x is negative 3x, still minus 22. All right, just finish solving. So I'm going to combine like terms on the same side. 270 minus 22 would be 248. So 248, and I still have minus 3x. Don't get the signs mixed up of those things. Then I'm going to get my like terms on same side. So I'm going to add 3x so I can get positive x's. I'm going to go ahead and then subtract 180 on the same step. There's just 2 linear steps together. That's perfectly fine. And that will give you 68 divide by 2, and x equals 34. Now, is that my answer? Is that what I wanted? Yes, I asked you for the measure of the angle. I didn't ask you for the measure of its complement or its supplement, the angle. So since I had x as my angle, then that is my final answer, is just 34 degrees. And we can put the degree sign or not. Either way is fine. All right, that's it for number 10. Now we're going to look at number 11 through 14. So some of us really struggled with this. Here's what I suggest. Go to IXL. I have plenty of practice, or they have plenty of practice problems. I posted the link in Google Classroom on our IXL links document. It's right there. You can get practice all day on this stuff, just identifying them. It's really important to be able to identify them. So when it says name 2 angles, it means a pair of angles that are vertical angles. So I'll just highlight some pairs of vertical angles. So here we've got this angle. Do you see what the vertical angle is? This one, because again, they share a vertex, right? And their non-shared sides form opposite rays. So this non-shared side shares an opposite ray with this non-shared side, and this one, and this one. Okay, so it actually forms 2 pairs of vertical angles. So these 2 are vertical angles, and these 2 are vertical angles. So that's an example of vertical angles. Let's do another one. How about this one? JAH. Well, look, here's an opposite ray to ray AH, and an opposite ray to AJ. So those 2 are vertical angles. So that would be this one and this one. Oh, you could also say this one and this one. That's another couple pairs of vertical angles. Here's a pair that are not vertical angles. ACB and DCB are not vertical angles. Why? Because they have a shared side, not vertical angles. So there are more examples than that. Okay. All right, for a linear pair. So I just did lots of examples in case you're trying to, go through the video and find the pieces that you need. So right here, 2 angles that form a linear pair. So just a pair of linear angles. A linear pair, right? A pair of angles that are linear, form a linear pair. So they just have to form a line, right? So they're non-shared sides. So JAH right here, do you see the angle that would then make a full 180 degrees? So it would form a line. I see it. We could have HAB here, like that, right? Because then we can see that from here to here and then here to here would make full 180 degrees. Oh, if you don't like that one though, guess what we can do? We can actually not do that. We can do JAH again. Sorry, it takes a while to erase. And we could actually do this guy over here, this way. Because that also would be, full 180. So if you have a pair of vertical angles, then you can, in those vertical angles, you can pair them up differently and it'll form a linear pair. So, because we had JAH as one of our examples for a pair of vertical angles. So vertical angles and linear pair are not the same thing, but you can take two intersecting lines and you can say these two are a linear pair, these two are a linear pair, these two are a linear pair, and did I get them all? These two, these two, these two. Yeah, you have 3 pairs. No, you should have 4 pairs. I missed this one. From here to here would be a linear pair. Okay. But then in that same set of angles there, you would actually have 2 pairs of vertical angles, right? You would have these and these. Okay, as pairs of vertical angles. Okay, so linear pair, lots of different examples. So I could do KDC here, right? And then I could come in and do HDG. That would form a linear pair because look, 180 degrees. So find a vertex and then find 2 angles. They share a side and their opposite rays form a line. So vertex, shared side, these 2 are opposite rays. That'll be a linear pair. Okay. All right, 2 angles that are non-adjacent. A lot of you gave me angles that weren't even drawn, like saying AJH. That angle is not drawn at all, which, okay, you can use it, but why? Do you think that's why it's not adjacent because it's not drawn? That's not true. Just any 2 angles that don't share a vertex and a shared side. So JAH, okay, that angle right there, it has this angle, JAC is an adjacent angle, and then HAB is an adjacent angle. Since we went non-adjacent, you can literally name any angle besides this one and that one. Okay, so over here, that would be a non-adjacent angle with JAH, or over here, or over here, or over here. Just tons of different angles, as long as they don't share a vertex and they don't share a side. Those are non-adjacent angles. So it's just the opposite definition of adjacent angles. It breaks either of the things. So for adjacent angles, they have to share a vertex and share a side. So if it breaks one or both of those things, then they're non-adjacent. All right, 2 angles that are complementary, there are only 1 pair. Complementary means 2 angles that add to 90, not just a 90-degree angle. That's called a right angle. So if you said ACB, no, that is a right angle by itself. So it's not complementary. That doesn't make sense. Complementary angles are a pair of angles. So 2 angles that add to 90. There's only 2 that you could have named here because those are the only 2 that are marked with actual degrees. So angles CAB, which is this one right here. And if you named it DAB, that's fine too. There's different names for it since there's more points along this side of the angle. But that's 50 degrees. And then this 40-degree angle, so CBA is what I'm going to name it. So those are a pair of complementary angles. Okay, and number 15 we didn't do for the construction. All right, that's it for this video. If you want help on measuring angles, I have another video for that. Thanks for watching.